Hello and welcome to the channel. My electric car build continues. In the last episode I was working with FOC tuning and I connected my resolver and set up a Syncofs coefficient that would allow me to adjust magnetic fields of the stator and rotor correctly. In this episode I will continue to work with FOC tuning and will implement a throttle control. Hello, I'm Ed and I'm building an electric car conversion. I've spent a few weeks working on the Toyota Prius inverter and the open inverter board. The challenge I set myself is to build an electric car conversion on the budget. Therefore, I was choosing components for my project very carefully. So far, I managed to purchase an inverter at a very good price. And now I acquired Toyota Prius gearbox, aka my electric motor. I've got the motor spinning now in the sine mode. Next, I will need to crack the puzzle of the FOC tuning and start working on the batteries. Okay, I've just connected the start inverter button to the amp seal connector. So effectively it's a pin 5 on amp seal connector. It's a momentary switch, we just press it in, it applies the voltage. And here is our throttle pedal. So that's the one which I connected pretty much the same as in my last video. It's a Toyota Iris, or maybe the same as Toyota Prius pedal. It has wiper 1 and wiper 2, which is one for regen, another one for acceleration. Yeah, basically 5 volts power and ground. So this cable is connected to the amp seal connector. So I'm going to try to use now throttle control, and I'm going to use the Syncofs value which I found in the last video. Right, here we go. The power supply on. So that's powering an inverter, and now the high voltage supply going through the bulb just to pre-charge. This one is on, and now I'm just gonna press the start button. You can hear a bit of a whine. That means that inverter has started. And now we have a throttle control. But anyway, yay! We actually succeeded. So the Syncofs value that I found seems to be working well. Let's have a look at the graph. I plot the graph of the resolver. So we are getting variable speed. Yeah, it seems to be working. I'm not really sure why. It seems to be accelerated more at the beginning and then less. So now you can see this, my pedal control. Another little success. And lastly, I did a little experiment where I enable current sensors IL1 and IL2 and plotted the graph of resolver angle and current sensors. On this graph we could see how current changes with the application of the throttle and angle change relatively to the current. With MG1 job out of the way, I swiftly reconnected the cable over to MG2. It was actually much easier because the cable itself was made for MG2 in the first place, and I've just used it for MG1 while I was doing the testing. And now I could fit a proper Toyota cover, which will provide an extra shielding for the high voltage cables for the motor. And the last but not least, I moved the resolver wires to the resolver for MG2. So now they were all labeled, and of course that was much easier to do than the first time. Just in case, I did check the resistance of the wires to ensure that I appropriately connect exciter and resolver. Okay, I'm just trying to show you the parking brake. So this is the one, and I think I'm gonna have to remove it, but I will just try it with it on, and we'll see whether this MG2 will rotate. I suspect it should not. We will find out. Oh yes, the brake was on, but I was hoping of course that it wouldn't be on, and as they say, the hope dies last. Okay, set inverter in manual mode, manual ID 10, and go. I should have listened to Professor Kelly.
Now if I move the lever up and down, you can see the parking pole move in and out, which is what it would do in the gear and keep it from rotating.
Never mind. Oh, let's see if I can back out of it. Manual ID -5, go. Oh well, looks like I will have to do it hard way. At first I thought I'd have to remove parking brake actuator to allow me to rotate the spline to disengage a parking clamp. It turns out once I removed the 3 fixing screws that fixed actuator to the gearbox, I could actually rotate it quite freely, and I could position it in a way that it should move parking pole into the position where it would allow motor to rotate. Well, that's the theory anyway. Will it work? Well, who knows? There is only one way to find out. Yay, I managed to find the position for the parking motor where the parking brake was released. And notice that obviously now we have MG1 rotating as well as the actual, wheel gear. What I decided to try is to fix this motor into the position where it would keep the parking brake released. I hope it hasn't moved since I found the position. We'll find out in a second. I'm just gonna fix it. Okay, and now quick test. Right, I've just tried manual ID 5 and it looks like I managed to keep the parking brake in the right position. Yeah, you can see now that's ring gear working, so if I hold it I can actually stop it, so it only rotates this, so I'm not able to stop MG1 on its own. I performed tuning pretty much in the same order as I did with MG1, only I found the Syncofs value was much higher for MG2 in comparison to MG1. The final Syncof value was found at 20,200. Now I'm gonna try and verify, see if it works with the throttle control. It's working with the pedal, baby. Look at that beauty, it's going. MG1 and the wheels. That's well done. Let me show you the pedal and me controlling it by hand. And that control rotates this little thingy, so-called electric motor. Here we go. Unfortunately, I found in time the lock brake is beginning to creep in and you can hear clanking of the lock brake against the gear. But this is something for me to worry about in the next video. If any of you know how I can control electrically parking brake, please let me know in the comments. A like and subscribe if you want to see more of this, and I will see you in the next video. All the best.